4 items which we call elements of petroleum. We have what we call the source rock. Source rocks are generally rocks that are rich. They have a tendency to be able to produce hydrocarbon or petroleum. So they are so rich in or the content that produces hydrocarbon that we call them source rock. We have carrier beds, which could also be, sometimes part of a source rock or what we call reservoir rock. But the key thing is that they are typically migration pathways, helping to go from the source to the reservoir. We also have a reservoir rock. Reservoir rock is like a storage tank. Any rock that has the capacity to keep petroleum or hydrocarbon is called a reservoir rock. It could be what we call siliciclastics. It could be carbonates. But in this part of the world, in Nigeria, in most part of Niger Delta, we have dominantly what we trap is basically any configuration that can keep hydrocarbon in place, right? Arrangement of rocks that can keep hydrocarbon in place. While a seal is a rock that can prevent hydrocarbon from escaping further to the surface. So the geochemists, this is their job. And then they go ahead to give us a picture of the sequence of what happens. I told you the source rock is a bunch of living organisms, plants and animals dead that have been buried together with what we call sediments. And as the depth of burial progresses, as it gets buried deeper, one on top of the other, it gets converted in the absence of oxygen to what we call kerogen, which is more like an intermediate item. And then with further burial, increase in temperature, increase in pressure, conversion of that organic matter content of the rock to a different form, oil is generated. And then if that continues, it gets to another phase, gas. So you get oil first and then followed by gas, because each of these have certain range of pressures and temperature that they are very stable. Gas is where things have gone beyond normal. That's where you find gas. And this is the same principle that we use in exploration. We expect to find oil in a certain range of conditions. And then as you go much deeper, where things are more intense, you'll find less of oil and more of gas. Now, a little bit about kerogen. I think I'm going to read. I'm not going to read this. What I will say is that kerogen is the intermediate member between the organic matter that was buried, and then the oil and gas that we have. It's largely an intermediate product that is very complex. Very complex. A lot of work has been done on the content of kerogen. It's very complex. But the key thing is that the trajectory of the conversion of kerogen determines what you get. What ratio of oil and gas do you get? What kind of oil? Is it heavy oil? Is it light oil? Is it more oil than gas? So that is all a function of the content of the kerogen. Is it dominantly plant source? Is it alga or other source? And then what is the condition? How did it progress in terms of burial? That determines whether you're getting one type or the other. So now we have what we call different types of kerogen. So type 1 kerogen, this is the property. They are largely formed from proteins and lipids. Of course, proteins and lipids are things that we're probably familiar with. Okay, so they readily produce liquid hydrocarbons. That's one thing with type 1 kerogen. Most people in the oil and gas are happy with this because we like oil, right? Of course, we like gas too a lot, but dominantly people like oil because, again, type 1 kerogen, this is the property and this is where it comes from, and this is what is the precursor for that. The hydrogen to carbon ratio is there, oxygen to carbon ratio is there, but largely these are largely of bacterial, freshwater algae, and some plant content. Type 2, similar, but I think the key difference here is that type 2 kerogen ends up giving us a mixture of oil and gas. That's the key thing I need you to take away. Type 2 kerogen, mixture of oil and gas. And then we have other types of kerogen, type 3, which has its hydrogen to carbon ratio and all of that. But the material is mostly gas, what it produces. And that is largely because the content of type 3 kerogen, the precursor or the parent, is mostly of plant matter. What that means is that what was buried in the absence of oxygen, if it is where it is dominantly plant content, you'll be getting type 3 kerogen. And what that will give you in the long term or as a product will be mostly gas. And then we also have other types. The one that has, that one that is type 2, oil and gas, but rich in sulfur, that is called type 2S kerogen. And then type 4, which is another form that is mostly a bunch of aromatic hydrocarbons.